Welcome to my presentation. Today I'll explore how drones and autonomous technologies can be used to address climate change and evaluate how effective they really are. I'll be focusing on their uses in agriculture, emissions tracking, and ecosystem monitoring. I'll also be analyzing the strengths, limitations, and ethical challenges that come alongside it. Climate change brings in rising global temperatures, extreme weather, glacial melts, and even deforestation. These threats not only impact ecosystems, but they also impact human society and economies. Currently, people are approaching these with the use of satellites and ground sensors, but they often fall short. Satellites lack fine detail, while ground sensors can cover large areas quickly. Drones, on the other hand, offer a way to collect high-resolution, real-time data in places that are too costly or dangerous for humans to reach, which makes them an increasingly important tool. One major use of drones is in agriculture. Drones are equipped with sensors, which allows them to scan fields to detect pests, monitor crop health, and optimize irrigation. Instead of using pesticides across entire fields, drones have the ability for specific targeting. This reduces chemical use, conserves water, and even cuts down on waste. By utilizing these applications of drones, they make farming more sustainable and resilient against climate threats like droughts. Aside from drones being effective, drones can help farmers prepare for unpredictable weather. With the high-resolution data provided by the drones, they can reveal early warning signs of stress in crops before they are visible to the human eye. This allows farmers to act early, potentially saving harvests during droughts or extreme heat. By improving these decision-making skills and reducing overuse of water or chemicals, drones not only support farmers but make food production systems more sustainable. Drones are also transforming ways in which we monitor gas emissions. One of these ways is using reinforcement learning. AI-guided drones adapt their flight path in real time to locate carbon dioxide hotspots. This is more accurate than traditional methods, which rely on fixed sampling routes. Precise emission data is critical for improving climate models, verifying national strategies, and policies. Despite there being progress, the usage of drones for emissions monitoring faces many problems. Some of these problems are that advanced sensors and AI systems are expensive and require skilled operators. Also, legal frameworks often limit flights over industrial or urban zones, where data is most needed. These challenges highlight that drones are powerful in theory, but their practical use is constrained by cost, regulation, and access. Unless these challenges are addressed, the potential impact on emissions reduction will be limited. Drones can also be helpful to ecosystems. Natural ecosystems like forests are vital to climate change. Forests act as vital carbon sinks that absorb enormous amounts of carbon dioxide. Drones can be used to protect them, such as in Belgium, researchers use drones with 7 advanced systems to monitor tree health, drought stress, and disease. Flying above the canopy, drones were able to detect threats before they were visible. This early warning allows us for a quicker intervention, which in turn keeps forests healthier and more capable of capturing carbon. Although drones are valuable for ecosystem monitoring, they face significant challenges. Forests and oceans often cover vast areas, and drones have limited flight times and battery life, which restricts coverage. Also, weather conditions such as heavy rains or strong winds can ground drones or damage equipment. Data analysis is another challenge since collecting large amounts of environmental data requires powerful computing systems and skilled technicians. Looking at the strengths, drones are flexible, very cost effective compared to satellites, and they are able to reach inaccessible regions. They also deliver high resolution quality data and real time data, which are faster than traditional tools/methods. They can also be deployed quickly in response to various climate disasters, such as floods or wildfires, which will then provide us with helpful data for when we need to respond to other emergencies. However, its effectiveness is limited by various challenges. Advanced drones are very costly and require skilled operators, which many communities lack. Also, regulations in airspace restrict where drones can fly, especially near cities or industrial areas. There arises ethical issues, such as drones may be seen as invasive, which raises concerns about surveillance or data being misused. There's also the issue of equality. Many wealthy nations and organizations have the ability to afford drones, but poor ones don't, which in turn creates an uneven benefit. In conclusion, drones and autonomous technologies are powerful tools in the effort to combat climate change. They help enrich agriculture, track gas emissions, and also help monitor ecosystems with precision and accuracy. These technologies help us extend our ability to gather data and make informed decisions, which is essential for combating against global climate change. While these may be effective in many ways, they cannot solve the whole climate change on their own. The biggest obstacles so far remain to be cost, regulations, and accessibility. Welfare nations and organizations currently have greater access to these tools, while developing nations may be left out. Without global cooperation and investments, the benefits of drones could deepen inequality rather than reduce it. Also, ethical concerns like surveillance and data misuse need to be addressed for drones to be trusted and widely adopted. In the future, advances in AI, battery life, and regulations may make drones cheaper, smarter, and more widely available. As a result of these, drones have the possibility of becoming one of the most sought out tools to combat global climate change. But for now, their effectiveness is limited, only being used for adaptation and monitoring, and maybe for some solutions.